Okay, everybody, this is some of the last notes you're going to get of the year. Talking about acids, bases, and salts. So let's ask the first question. What is an acid? Well, an acid is a compound that has a pH less than 7, and we're going to get into pH a little later on in this video. An acid will neutralize bases. We'll even talk about bases a bit in some other video. They form hydrogen ions in solution, and they are corrosive. They react with most metals to form hydrogen gas. Acids are good conductors of electricity. Okay, so here's a general equation with an acid, okay? What we have here is a nitric acid plus water, and when that combines, we form H3O and NO3. Those are the ions that dissociate in solution, okay? H3O is really called a hydronium ion. So let's take a look at weak acids versus strong ones. Weak acids do not what we call ionize completely. That means they do not dissociate into water. We just got done with dissolving, so I guess you can compare that to salt not dissolving all the way in water. They don't ionize completely. They don't break down into its component parts. So here are some examples of strong weak acids. We have acetic acid, boric acid, nitrous acid, phosphoric acid, and sulfurous acid. I know it sounds like sulfuric acid. Sulfuric acid is actually a strong acid, and that is an acid that ionizes completely. Hydrochloric acid, one you're commonly use in chemistry, nitric acid, sulfuric acid, and hydroiodic acid. So again, here are some examples of common acids. The HCl is the hydrochloric acid. That is a stomach acid, and what protects the lining of your stomach from that acid is mucus, so it doesn't burn a hole in your stomach. H2SO4 is sulfuric acid. You find that in car batteries. It's a very strong acid, very strong. HNO3 is nitric acid. Find that in explosives. Acetic acid is in vinegar. That's a pretty weak acid. Carbonic acid, you find that in the soda pop quite a bit. And H3PO4, which is phosphoric acid, you'll find that in flavoring. So you find a lot of acids in different lot of products. Okay. What is a base? A base is a compound that has a pH of greater than 7. Remember, water has a pH, pure water has a pH of 7. Okay, it is a neutral compound. Bases feel slippery. They dissolve fats and oils. They usually form what's called a hydroxide ion in solution, and they neutralize acids. Weak versus strong bases. Here we go. Some weak bases are ammonia, potassium carbonate, sodium carbonate. Some strong bases, sodium hydroxide, sodium phosphate, barium hydroxide, and calcium hydroxide. And so here are some of them. Sodium hydroxide you'll find in soaps, also called lye. Sodium hydroxide, the strong sodium hydroxide, a drain cleaner. You don't want to get that stuff on your skin or in your eyes. Magnesium hydroxide, if you have upset stomach and a lot of acid, take something like Tums, something like that. Aluminum hydroxide, you find that in antacids. You also find that in deodorant products. So a lot of those things contain bases. And then we have ammonium hydroxide, which pretty much is ammonia. It's a pretty good base. Types of acids and bases. So we're going to ask you to know two types of acids and bases. One is called Arrhenius acids, and what those kind of acids do is they produce hydrogen ions in water, and Arrhenius bases produce hydroxide ions in water. Now, we're going to compare that to a more modern concept of acids and bases, and they're called Bronsted-Lowry acids, and they're also called Bronsted-Lowry bases. So Bronsted-Lowry acids donate a hydrogen ion in a reaction, where Bronsted-Lowry bases, they accept a hydrogen ion in a reaction, basically forming a base. We'll get some practice with that later in the week. All right, another term you're going to need to know. A conjugate acid, that's a compound formed when a base gains a hydrogen ion. Okay, it's not the acid, it's called a conjugate. A conjugate base is a compound formed when an acid loses a hydrogen ion. Okay, so that may be a little tricky for you. Conjugate acid means a compound that is formed when a base gains a hydrogen ion, and a conjugate base is a compound formed when an acid loses a hydrogen ion. Okay, and in fact becomes a base. Now this is the pH scale we're looking at, and neutral is right in the middle. That is 7 for the pH scale. It's a scale that goes all the way from 0 to 14. You can see on here approximate pHs for certain substances. Lemon juice has a pH of 2, and that's right over here. That's a really strong acid. The lower the number is for an acid, the stronger it is. White wine, pH of 4. Rain, a pH of 5.5. So rain is slightly acidic. Human blood has a pH of around 7.5, so it's a little bit alkaline, a little more basic. Baking soda, a pH of 8.5. That's why baking soda is so good at neutralizing stomach acid. Detergent, it's a base, around 10. The higher the number up on the pH scale, the stronger the base is. And bleach has a pH of around 12.5. Really, really strong base. Okay, we'll do some more with pH in this last week. And here we go with some more of that. We have neutral right in the middle with 7. That's where the hydrogen ions and the hydroxide ions are equal. Water, pure water is at 7. Drinking water is around 7.2, so it's a little more alkaline, a little more basic. Blood, a little higher than that. So detergents typically end up in the 8 to 9 pH range. Seawater, relatively alkaline, pretty basic, 8.5. If you look down on the acidic scale, 0 to 6 or 7, I guess you say, milk is slightly acidic, even though they use milk for when you have really hot foods, spicy foods, really acidic ones. Milk helps to neutralize that acid because it's a little higher up on the pH scale. Urine, potatoes, bread, look where bread's at. Coffee at 5, tomatoes at 4.2, apple juice, look at all these juices. Carbonated beverages have a lot of acid in them. They aren't good for you. Lemon juice at 2.2, and your stomach acid at around 1.6. So you kind of get an idea how strong some substances are. If you look over on the other end, we have bleach at 12.0, and sodium hydroxide, lye, is very, very strong base. So anyway, we don't need to worry about this part. pH paper, we use pH paper to determine whether a substance is alkaline or acidic, okay? And we tell by the color of the paper change. We may have an activity using water to see how your bottled water or your tap water, how alkaline or basic it really is. I don't have to worry about what a buffer is. Some situations where we control the pH, heartburn. So when you have that upset stomach, you need to have a base to help control that because that's really acidic. And so you need a base for that to help out, something like Tums or milk of magnesia, something like that. When you plant flowers and vegetables, you ought to make sure you have good pH in your soil. Fish tanks and ponds, you don't want it too acidic, you don't want it too basic because you're going to kill whatever life you have there. Blood, you want to have a slightly basic pH for blood. And swimming pools, you don't want an acidic swimming pool, you want something that is basic or alkaline, but not too much, because that's really going to be irritating to your skin and to your eyes. Okay, so these are your acids and bases in solution, and these are the equations for them. Right in the blanks there we have the yield sign. Just some information for you, and we'll practice that later on. And acid rain. Acid rain, when you combine carbon dioxide in the air with the water in the air, they combine to form various acids, and it's pollution. And acid rain does a really good job in killing animal life, especially in lakes and rivers, streams, ponds, uh, and even in the soil. You can see here's examples of what acid rain can do. It can cause sinkholes, it can harm fish, it can kill trees, it can wear away rock and stone, which it does, and even form sinkholes in other parts of the world. It's this cemetery in Georgia. And another sinkhole over here. This is why climate change is a really bad thing, and acid rain is a big product of that. A salt, it's a neutral substance produced from the reaction of an acid and a base. So that's a nice definition for you. It's composed of a negative ion of an acid and the positive ion of a base. And it's a product of a neutralization reaction. That's when an acid combines with a base. So we have these are examples of salts. Remember, they are neutral substance. It's a neutral substance. So here's a neutralization reaction. Reaction with an acid with a base to produce salt and water. So here's our acid, H2SO4, which is sulfuric acid. And we have sodium hydroxide. Here's our base. And what we do is we produce a salt here and water here, for example. So anyway, I'm not going to get into this stuff right here. But this is kind of the gist of the salts, acids, and bases, and hope you take good notes. Now, what I need you to do is go to the naming acids video, take notes on your Cornell notes sheet, your C notes, answer the questions to the video. Then you go to the naming bases, take notes on your C notes, and then answer the questions in that video too. It's a shorter video. And that's it.